So, hello everyone, I'm Joanna Przystawska from the European Environment Agency, and today, together with Jean-Etienne, we want to present you how to use WEkEO. And I have a just short introduction, and then Jean-Etienne will be presenting online. So, yes. So you may ask why Copernicus use WEkEO. So together with developing technologies, we can see that there is a higher resolution, spatial resolution, but also temporal resolution, and much more storage space is needed. That's why we're looking for a solution. And then there is also a problem with processing these large volumes of data set. So Copernicus is an answer for that, and we first have a storage capacity, but we also have processing environment that can be on cloud, can be on virtual machines, and this is what we want to today present for you. So what is actually WEkEO? On their website you can find this citation. WEkEO is the EU Copernicus reference service for environmental data, virtual processing environments, and skilled user support. What does that mean? It's actually that it's initiative of European agencies, EUMETSAT, ECMWF, and Mercator Ocean that EA joined just recently. And you are provided with harmonized data access to all Sentinel data and all 4 environmental Copernicus services. Also, it gives you access to data exploitation services, and IT processing environments for free offer. There's free offer, but also paid services. And lastly, we have technical and thematic support provided. So just a quick overview of our CLMS product portfolio. You probably are familiar. What data is available on WEkEO? We have priority area monitoring data, so the one that focuses on areas prone to some environmental challenges. Then there is also biophysical parameters monitoring, the one that Ludwig mentioned. So this one is data sets that control energy budget, also terrestrial cryosphere variables, and vegetation dynamics and water cycle. And then we also have land cover and land use mapping. Consists, for instance, with Korean land cover products, but also our high resolution layers that gives you characteristic of land use and land cover. And then we have also reference data available. Amongst them, there is our EU digital elevation model and EU hydro. And European ground motion service is not available on WEkEO, but there is a next session following that one, and you will get more information how to access this data. And today, actually, we will focus on these 2 products. There is high resolution vegetation phenology and productivity. And you can see how the data actually looks like. Here you have a snapshot of rolling dates of agricultural fields with a PPI, which is Plant Phenology Index for efficient monitoring of phenology. And you can actually see how the dates now, it's in winter, you have values in a blue color, which is 0, and then during a summer period, it goes to this reddish values, so a higher PPI. And then the other products is high resolution snow and ice monitoring, and here you have a KIF to show you fractional snow cover. This is a fraction of a snow on the ground and on top of canopy, and you can see actually this snapshot is from Madrid, from 2021, and it shows you how exactly when it's the white picture, it shows when there is 100% of a fractional snow cover, so when the snow fell, and then how it melted, it goes to 0 and the black values. So now I would like to give the floor to Jean-Etienne to give you demo hands-on how to access the data.
So hello everyone, my name is Jean-Etienne. I'm working at the WEkEO user support team, and I'm going to present you today how to use WEkEO and its services to access and download and process data. First of all, when you are going on WEkEO, you are going through for everything I'm going to show you, you need to have an account registered in WEkEO, so you can just click on the register button on this page when you go on the wekeo.eu address. It will be in place of the dashboard. So once it's done, you will have the menu, and on clicking on data, you will have access to the graphical user interface of WEkEO. This is what you will see when you go on this page. What we can see, it's a map of the Earth. On the left, we have the layer and jobs tabs, which I will explain later what they are. But as we can see, we have already 2 datasets selected by default. On the right here, we have several options and tools we can use. Locate is for putting a point at a specific location. Measure is for measuring 2 points, the distance between 2 points. Set AOI for area of interest is a useful tools we will use later for selecting an area we want data, and other stuff. On the bottom page, you will have the timeline. It's to see from when to where the data are available. And on the right, you will have a depth line. It's really useful most of the time for the marine marine data set, of course. On the left, as I said, we have the list of our selected data sets. By default, we have a land and a marine data set. Under each data set, we can see several buttons. The first one is for downloading data. It's for showing the different variable possible to select to download data. We have the information points. We can modify the opacity of the dataset selected. We can select other variable from the same dataset. We can show the color on a log scale, or we can use vector instead of color. For the example, I'm going to use the high resolution vegetation, phenology, and productivity dataset. So I'm going to remove the 2 datasets present. I can either click on the cross or just click on the eye to just remove the information, but still keep the dataset on the list. I'm just going to remove and click on the plus button to access to the catalog. The catalog is the place where I can select and search for the information I need. On the right, you have the full list of all our datasets, and on the left, you have several options you can use to select the dataset you need if you don't know the particular name of the one you want. So, for example, as I said, I want the high resolution vegetation, phenology, and productivity. So, as I know it's from land, so I select land. I know it's in Europe, and I can see the options that are already selected. I have phenology. By clicking on it, I will have the 5 datasets we have on WEkEO about phenology and productivity data. For example, I can use to scroll and select the last one, the vegetation, phenology, and productivity yearly on the projection. And by clicking on the star, I just add to my favorite. By clicking on details, I will have all the details of this dataset of the dataset. Yes, for example, the lat and lon extent, the ID of the dataset when it was published, who is the provider, etc. When I go back on the list, so I said I use this one. I'm going to click on Add the map, and these datasets have several variables, and I will select one. For example, again the last one, the total productivity for the season 1, and I click on Add to map, and I can then click on the cross or click on the screen. Here we can see over Europe we have our data. I'm going to click on the download button to see all my options available to download and select the data in it. So as I said, we are going to start with a bounding box. So I'm going to use the object set area of interest. And I will select over Belgium. Sorry. I will select an area, for example, like this. And I will copy array from map. Once it's done, I'm going to select timestamp. As I know, as I said, the dataset is yearly, so I need one full year at least. So I'm going to select on the timeline from 2019 to 2020. So I just can select, click on here and just copy from layer, or I can just write it directly. And the other option is not mandatory, as there is no little red cross next to it. So I can directly request my data. By doing so, it will send to the WEkEO server the request, and I can monitor it here. So it will send me to the job layer. The jobs is a list of all my previous requests. As I can see, the request I just did is already completed, and I have the list of all my previous requests I did earlier. By clicking on the folder icon, it will show me all the results I have. So for the area selected for the full year of 2019, I have 21 results. I can click on order. I will wait a little time, and I will be able to download them. By doing so, I see I have 21 results. This can be sometimes a little long manipulation. So we have developed an API which called Harmonious Data Access for HDA. And this dataset allowed me to download directly all the data I need by doing a request. I can find directly the request I need by clicking on the button next to it. And here I have the API request. As I see, I have several information I already know, like the dataset ID I selected, the bounding box value I used, or the data range select as I just used. So like I said, the 2019 year full. So I can click on the button to copy it, and I'm going to use one of the services WEkEO provide, which is Jupyter Hub. The Jupyter Hub, what is it? It's a services you can access on clicking on dashboard, and then waiting, you will have a button to click to access to your Jupyter Hub server. Jupyter Hub server or server provided for each user. Each user have storage space up to 10 gigabytes and specific arborescence. So I can click on this button and it lead me to my Jupyter Hub server. When I arrive for the first time, I will have this. I will have an old files folder and a public file folder. The work folder is a folder I already created myself. The public folder is a read-only folder when you have access to several notebooks already created by different provider from WEkEO. So you have, if I go on them, you have WEkEO atmosphere, climate, data, land, ocean, etc. And inside you have some notebooks you can use if you want, just to understand how to use the API or just to see other works from other people. If I come back, I go to work, and I already created a notebook that will show you how to use the HDA IP. So it looked like this. Once I install it, once I import my HDA client, I just instantiate the client. Sorry, as I said, I just copied the request, so I'll copy it inside the request. So it was already done beforehand, but you just have to copy, you execute it, and once you generate the request, it will show you the search result. So I already done beforehand a request, so I'm going to use to do it again to show you. So the request is done, and now I'm going to ask for the request, and I'm supposed to have 21 items. So here we have 21 items. We can see it's up to 5.7 gigabytes, so it's okay for our 10 gigabyte limit. And I can then download my data. I won't do it now because it can take a little time. So as you can see, I already done for another request on the same dataset. I have the list of all my datasets, and I specified a repository when I want them to be downloaded. So it have been downloaded on my chief folder, and when I open it, I have all the data I wanted. So as we can see, just here, so VPP 2019, S2, etc. And using the Jupyter Hub, you will be able then to process the data, display it, and then use it for any researcher or other activity. For example, this code here just take one of the chief data, the chief the GeoTIFF files, and just display it with information, as you can see. When I come back to the data area, so the graphical user interface, if you have any question or issue, you can contact us directly by clicking on this icon. It will open the chat, and you can either look to ask her directly for a question, or you can look for any articles that can help you. So, for example, if I write HDA API, I will have some error I can encounter, or how to set up my WEkEO Jupyter Hub to download WEkEO data, and so on. You can contact us directly via the chat, or use the mail with the address support@wekeo.eu to contact us directly. We have another thing. When you click on computing, we have already some notebook that are created, and you can explore them here. And you will have some data set, some notebook, not always on the land. Sometimes it's for all the WEkEO, so all the Copernicus services. So you can just scroll and look at them. Here you have the different options. You can either search directly or go on the land to select the different notebook we have. And finally, we have a help center where you can find, as I said, all the article. You can directly again contact us using this icon, or just select and look at any article you want. Thank you for your attention.
All right. So after this comprehensive demo on WEkEO portal given by Jean-Etienne, now I would like to present you with yet another example accessing high-resolution snow and ice data that will be followed by Jupyter Notebook demo case. So here you can see a Python client for accessing a Copernicus land monitoring service by HTTP API by means of REST calls. This one is currently supported on a server side only for snow and ice product. It's user-oriented access that allows parameterized search and bulk downloading. You can see the link to the GitHub repository here that allows you to find the script. And this is how the script looks like. The help for this script can be obtained by command python clms downloader.pa help. And that command will give you all parameters required for accessing high-resolution snow and ice data with explanation. So as you can see, you can need to provide output directory, for instance, your CLMS credentials stored in a TXT file, or product to be downloaded. Here we query for SAR wet snow product. And now I would like to present you with Jupyter Notebook demonstration case that is using Jupyter Hub on WEkEO. So as mentioned by Jean-Etienne, Jupyter Hub on WEkEO is an open source tool with a distributed Jupyter Notebook environment. So in that sense, user can log into the server and write Python code in a web browser without having to install software on their local machine. User can access processing scripts from WEkEO GitHub repository or load its own Python scripts to the Jupyter Hub. Jupyter Hub has limited storage and processing power, but can be a good solution for smaller jobs analysis or smaller data subset, or for users who only start their adventure with processing. So you can see here how to access, just to again show you that you need to first log in, click on the dashboard, it's highlighted in yellow, Then on the left, you need to choose Jupyter Hub. This is also the link provided. And then you have two server options. For this one, we are going to use Earth observation tools. And then you need to open script from WEkEO repository. So this is how it will look like when you open this Earth observation tool. And then you need to click on public folder. Then you have WEkEO for land folder. And then there is snow and ice folder. And you will find two scripts there, two notebooks. And we will focus on the second one. And this is how the scripts looks like on this Jupyter Hub. It's a demo case developed by colleagues from NVIDIA, and it analyzes wet snow extent from SAR wet snow time series, independence of altitude. And now we'll go step by step by this script to see how it works and how you can run parts of the script and what will be the result. These Jupyter scripts also are available on WEkEO GitHub repository. So as I mentioned, you can also run the script on your environment, for instance, on your Conda, on your computer. So important to mention here is that the analysis of this downloaded and extracted data needs to be done on your local disk. So you can use it on Jupyter Hub, but the data needs to be stored locally. We are working now on expanding GitHub library with scripts working with HDA client, so the processing could be done on the virtual machines. So just to show you an example of this script, these are 4 images of SAR wet snow over Switzerland. They provide information on the wet snow extent in the high mountain areas. They are Sentinel-1 data images. Time series is from 16 April 2018 to July 2018. So what you can see on these images is this magenta color. This is wet snow. You can see that actually this color is increasing through April to May. So more wet snow when the melting season has started. And then it's decreasing, and in July there is only very little wet snow remaining in the high mountain areas. So first you need to download the data, and how you do it you were already shown, either from WEkEO portal or using Python client, using scripts. And when you download SAR wet snow images, then you need to also download digital elevation model. Our digital elevation model is in 30-meter resolution, and SAR wet snow data are in 60-meter resolution. So remember to first resample digital elevation model to 60 meters, so they are both the same resolution. And this is how the scripts looks like step by step. So first you need to import required tools for Python. These are the Python modules and packages that are explained here, and this is the part of the code that needs to be run. So you're accessing running like first part and then the second and so on. Then in the second part, we are defining how to read GeoTIFF files. So these are just the standard function to read, open and read images. And this is actually the only thing that needs to be changed. So this is part where the script provides the path to the data saved locally on a computer disk. So here you have the path input. So this needs to be input for your data stored locally. And then there are also paths for SAR wet snow and digital elevation model data. So please just make sure that this also follow the convention, the naming convention. So as mentioned, digital elevation data needs to be prepared in advance. It is very important that it has exactly the same map projection and exactly same grid spacing as the product to be analyzed. So this is mandatory. 60-meter resolution needs to be resampled. And then in the next step, we plot digital elevation model just to see how the data looks like. And here we are using the standard color bar available from Python matplotlib. So the data will look a bit different than the one downloaded from WEkEO portal. In the next step, to see how SAR wet snow data looks like, we plot first SAR wet snow product of the time series, also using a standard color bar. And this is where the analysis is done. First, we define a step size of the elevation range. Here we take 200 meters as the interval of the elevation. Then we know that in the region of analysis in Switzerland, the elevation range is between 1,000 and 4,000 meters. So these are our boundary conditions. And then we analyze per elevation step how many pixels are included there, counting pixels in step 18. And 110 is the code value assigned in a SAR wet snow product for the class wet snow. So we extract elevation information for snow wet pixels and add it to a database. And here we prepare the figures, get the names from SAR wet snow product names, and we prepare a plot showing wet snow extent independence of altitude. This is our result. This is elevation distribution of the wet snow areas for different time steps. So what does it do here is that it reads all 4 datasets of the wet snow map that we were shown at the very beginning, and they are all analyzed with the same digital elevation model. And the result is how the wet snow areas are distributed in relation to the local height of this region. And this is considering the period from 16 April 2018 to 3rd of July 2018. So it's a melting season in the Alpine range. And what you can see is actually that the blue line, it's April date. So you can see that actually there is many wet pixels in the lower altitudes. Then the number of wet pixels is increasing, but is also on a higher elevation. So more wet pixels during the melting season, and then it's decreasing. Finally, in July, we have very little pixels, wet pixels, only remaining on the higher altitude. So we can see that the increase of the melting areas with respect to the time. And at some point, the snow remains only at the highest elevation, and this is what is then melting in the end of July. So this was the example of this analysis of wet snow extent independence of altitude. But there is also another script available, and I encourage you to check it out, that uses wet snow extent independence of altitude and aspect. It can be also accessible on Jupyter Hub. And in case of any questions, please do not hesitate either contact WEkEO support by accessing this website or to write to Copernicus help desk, copernicus@ea.europa.eu. Thank you.